Welcome to RJdatascience. Today, we're tackling a huge question for anyone building with AI. You've created this brilliant agent, it works great in your notebook, but now what? How do you actually get it out of the lab and into the real world?
Yeah, exactly. Creating a demo is one thing, right? But as Alex from the Vanishing Gradients podcast points out, once you have real users, real production data, well, that's a whole different ballgame. That's when things get complicated.
So we're going to guide you on this whole journey. We'll start with creating agents, and spoiler alert, that's the easy part. Then we'll face what I like to call the deployment gauntlet. We'll give you the production toolkit you need, show you how to test for the unpredictable real world, and finally, help you choose the right deployment path. Okay, let's dive in. Let's start with what feels like the easy part. And honestly, thanks to some incredible frameworks like CrewAI and LangGraph, spinning up a functional AI agent has become surprisingly straightforward. It's often just this simple four-step process. You define its tools, what can it do? Search the web, save a file, that kind of thing. You choose its brain, an LLM like GPT-4. Then you give it instructions with a system prompt. And finally, you tie it all together. And boom, you've got a working prototype. But, and this is a big but, this is where the hero's journey really begins.
Right. Now for the hard part. Taking that cool agent and making it work reliably in a production environment. That introduces a whole host of really difficult challenges. And this quote just hits the nail on the head. It's every engineer's nightmare. An agent's decision-making process can feel like a total black box. So what are the biggest obstacles you're going to face when your agent leaves the lab? And these aren't just minor bugs. They're fundamental challenges. Non-determinism just means the agent might give you a different answer to the same question every time. This makes it super unpredictable. Then you've got cascading failures, where one small mistake can spiral and send the agent way off course. With observability gaps, you're basically flying blind trying to figure out what went wrong. And of course, scaling fragility means it might work fine for one user, but it just falls apart under heavy load. To tackle these, you really have to shift your mindset from being a model builder to being a systems engineer. So to overcome these trials, our agent is going to need some powerful allies. Let's introduce the essential tools you'll need for a production-ready system. First up, your agent needs a front door. You can't just expect people to run a Python script, right? That's where FastAPI comes in. It's like a universal translator, wrapping your agent in a clean API so any other application or website can talk to it easily. Next, you gotta solve that classic problem, well, it worked on my machine. Docker takes care of this by packaging your agent plus all of its libraries and configurations into a self-contained container. This makes sure it runs the exact same way everywhere, every time. And this slide, it brilliantly illustrates the standard workflow. You build the agent in Python, give it a front door with FastAPI, package the whole shebang with Docker, and then it's ready to ship to a cloud service like AWS or Google Cloud. But hold on, before we deploy, how on earth do you test something that's fundamentally unreliable? I mean, traditional software tests that expect the exact same output every single time, they just fall short here. The answer is evals. Instead of checking for an exact match, you create specific test cases, scenarios, really, and you just define what a successful outcome looks like. Then you can run these evals over and over to make sure your agent's performance doesn't get worse as you make changes. I love this analogy. It's just perfect. It connects this new AI concept right back to a core principle of software engineering. Just like unit tests check little pieces of your code, evals check small, specific capabilities of your agent. It brings some much-needed reliability to the table. It's also super critical how you test. Experts will tell you again and again, don't use mock data. It's just too clean. It can't replicate the messy, unpredictable nature of the real world. The best way to do it is to create a realistic test environment and just let your agent go at it, live, just like it would in production. All right, your agent is built, it's been containerized, it's been tested. Now for the final step, choosing its home in production. Let's take a look at the options. You've got several paths you can take. There are specialized services like the CrewAI AMP platform that offer a really streamlined experience. Or you can go with the cloud giants like AWS and Google Cloud for maximum flexibility and control. And for simpler apps, something like Vercel can be a great way to get up and running fast. For instance, let's look at how AWS Bedrock does this. They've got a really clever system using versions and aliases.
A version is an unchangeable snapshot of your agent. An alias is just a pointer to one of those versions, so you can safely deploy a new agent version and then just switch the alias to point to it. If something breaks, no sweat. You just point the alias right back to the old version for an instant, safe rollback. And this table really clarifies the trade-offs. Your choice really depends on what you need. For a quick test from your own machine, the CrewAI CLI is perfect. If you're working with a team, a Git-based workflow makes a ton of sense. For a mature automated system, you'll want to integrate with an API. And for ultimate power and flexibility, a custom AWS setup is the way to go. So while building your agent might feel like you're at the finish line, it's really just the start. Getting it truly ready for the real world is a significant engineering challenge. It demands a new toolkit, a new way of testing, and a systems-level mindset. But with the right approach, it's a challenge you can absolutely conquer. If you found this explainer helpful, be sure to like, share, and subscribe to RJ Data Science for more deep dives into AI and data science. Thanks for watching.